Hello everyone, welcome to new class. Today's class is the basics of power system. So let us study about the one line diagram of a typical power system. One line diagram or single line diagram of a typical power system. So this is the one line diagram of a very simple electric power system. And the power station generally houses two or more three-phase alternators operated in parallel. Due to technical reasons, the generation voltage is not very high. It is usually 11 kV to 25 kV. The power stations are located at favorable places, generally quite far away from the consumers. Owing to economical reasons, electrical power has to be transmitted through transmission lines at a very high voltage. Therefore, voltage at the power station is stepped to a high value, that is 220 kilovolt by step up transformer. So these portions is at the power station. So this is power station. So the electric power is carried by the transmission lines at this high voltage, and the stepped up power is transmitted over the major distance and it reduces the line losses to a minimum. The transmitted power is stepped down in two or three stages before it reaches the consumer. So it is again stepped down to a suitable value to many stages. That is, there will be more substations. So the power is stepped down in many stages before it reaches the consumer. The 11 kV feeder. So this is at the substation. So the 11 kV feeders take the supply from the nearest substation to the distribution transformers, from which it is distributed to the consumers over service mains. So this is substation, then these are the distribution transformers. So distribution transformer which are nearest to the consumers. And this single line diagram represents a typical power distribution system, and an actual one need not be the same. It can differ in many ways such as step up and step down voltage levels, stages, number of feeders, service mains, and so on. So here the feeders carry the power to the distribution substation. So this is called distribution substation, which contains the distribution transformer, and feeders should not be tapped for direct supply. All the distribution substation, the step down transformer reduces the voltage to 400 volt, and distributors are used to supply power to various consumers. So an electric power system consists of the power station, then the transmission lines, then distribution systems. So that is about the one line diagram of a typical power system. Next is variable load on power station. The load on a power station varies from time to time due to uncertain demands of the consumers and is known as the variable load on the station. And a power station is designed to meet the load requirements of the consumers. An ideal load on a station from standpoint of equipment needed and operating routine would be one of the constant magnitude and steady duration. However, such a steady load on the station is never realized in actual practice. The consumers require their small or large block of power in accordance with the demands of their activities. Thus, the load demand of one consumer at any time may be different from that of the other consumer. The result is that load on the power station varies from time to time. And the variable load on a power station introduces many perplexities in its operation. Some of the important effects of the variable load on a power station are need of additional equipment. The variable load on a power station necessitates to have additional equipment. Consider a steam power station. So here air, then coal and water are the raw materials for this plant. In order to produce variable power, the supply of these materials will be required to be varied correspondingly. For instance, if the power demand on the plant increases, it must be followed by the increased flow of coal, air and water to the boiler in order to meet the increased demand. Therefore, additional equipment has to be installed to accomplish this job. As a matter of fact, in a modern power plant, there is much equipment devoted entirely to adjust the rates of supply of raw materials in accordance with the power demand made on the plant. Then second one is increase in production cost. The variable load on the plant increases the cost of production of the electrical energy. An alternator operates at maximum efficiency near its rated capacity. If a single alternator is used, it will have poor efficiency during periods of light loads on the plant. Therefore, in actual practice, a number of alternators of different capacities are installed so that most of the alternators can be operated at nearly full load capacity. However, the use of a number of generating units increases the initial cost per kilowatt of the plant capacity as well as floor area required. This leads to the increase in production cost of the energy. Next is load curves. The curve showing the variation of load on the power station with respect to time is known as load curve. The load on a power station is never constant. It varies from time to time. And these load variations during the whole day are recorded half hourly or hourly and are plotted against time on the graph. So, load versus time graph is recorded, and if it is recorded half hourly or hourly, Then the curve obtained is known as daily load curve. So this is called daily load curve. So if the load variations during the whole day are recorded half hourly or hourly and plotted against time on the graph are known as daily load curve because it shows the variations of load with respect to time during the day. So this is daily load curve. Then there is another one, monthly load curve. Monthly load curve. Then what will be monthly load curve? So monthly load curve can be obtained from the daily load curves of that month. For that purpose, average values of power over a month at different times of the day are calculated and then plotted on the graph. That is, average values of power over a month at different times of day. At different times of day are calculated and plotted on the graph. The monthly load curve is generally used to fix the rates of energy. Then there is another one, yearly load curve. Then what is yearly load curve? It is obtained by considering the monthly load curves of that particular year. The yearly load curve is generally used to determine the annual load factor. So daily load curve means the load variations during the whole day which are recorded half hourly or hourly and plotted against the time is known as daily load curve. Then monthly load curve obtained from the daily load curves of that month. That is, the average values of power over a month at different times of day are calculated and plotted, which is called the monthly load curve. Then yearly load curve is obtained by considering the monthly load curves of that particular year. The yearly load curve is generally used to determine the annual load factor.